Hey everyone, Dale here with Renewable Innovations, and I'm pretty excited to be talking to you about a particular project that I've been working on. So this is one that I've been consulting on, and I'm really excited to be able to show it off to you. So I got it up on my teleprompter, and we're going to kind of go over the scope of this project that I've been working with this electrician on up in the Simi Valley. Anton is a phenomenal electrician, does a lot of commercial stuff, and he had reached out to me interested in my assistance in basically getting him onboarded in the battery and solar sectors. Something he wanted to explore, not just for his own home, but for some of his neighbors and clients, as they've been asking him for years about getting batteries for their homes or getting solar. And it was just something that, as an electrician that just specializes in electrical work mainly, he hadn't really done it. He doesn't know where to start. And that's where, I feel I'm helping fill a void and offer my consultation services to electricians already, out there doing work, but maybe not doing it in the solar and battery space. With my assistance, I can help you get onboarded with various manufacturers, top producers like Franklin Whole Home Battery, Tesla, QCell, REC, Enphase, SolarEdge, you name it. We're here to help you get connected with these organizations. And then I'm also here to help you in your plan design and engineering, as I have engineers available for these projects. I can assist you with the permitting, help you with the NEM. Whatever you need guidance on, I have a fee schedule available for contractors for this, because if you only plan on doing 1-2 projects a month, maybe a quarter, you really don't want to bring on a full-time staff just for these one-off projects. But they do add to your portfolio, and they allow you to basically service a broader audience of clients that have gone green. So reach out to me here at Renewable Innovations. You can use the link down in the description below. Be sure to like, subscribe, and share this video, because this one is pretty cool. So this is a pretty big project. So let's jump over to it. So here we have the plans up. And what I'm going to do is I'm going to actually move this guy up here so I can see that everything's up there. All right, so check it out. We got our set of plans back. There were some revisions, some small changes with the engineering team, as I had input some information incorrectly, and then I told them later in an email when we were going back and forth about some other stuff. But this project is massive. It's 100 solar panels. And these are 430 watt JinkoSolar modules. We were originally going to go with QCell, but if you've seen anything in the news lately, you might be aware that the Customs has been holding up solar cells coming into the United States. So it's been causing some issues. So QCell modules probably not available unless you're buying them directly from QCell. So if you wanted a QCell system, I'm happy to help you with Axie by QCell. They obviously are the manufacturer and the installer. For Slazik Electric over here, different story, so we had to go with some different modules. But the JinkoSolar 430 watt modules, I trust JinkoSolar. I believe they are a pretty quality brand, in my opinion. You do a little research, you'll see some positive remarks. So if we zoom in over here, we can kind of get a little bit of the scope of work. As you can see, 400 or 100 panels, 43 kilowatts DC. We're at a 30.4 kilowatt AC system. We're using 4 Tesla Solar Inverters. Now these are string inverters, so we're trying to simplify the array. We wanted to make sure the entire system was backed up. And as you can see, there are 2 Franklin aGates, and this is really important because this is a 400 amp service, like a true 400 amp service. Now I'm not showing any of the client site at this time. I will be going out to this project and assisting Anton on the installation, commissioning, just going over general stuff with his electrical team, and then I'm obviously going to be documenting it to show it off to all of you. So be sure to like and subscribe. It really helps the channel, and I think you're going to really enjoy this installation because it's massive. Just to give you some perspective, this client's energy usage is around 60,000 kilowatt hours a year. Yeah, 60,000. Most homeowners are between 7 and 10,000 kilowatt hours a year. So they're easily 6 times that for most homes. And it's for good reason. They have a lot of electrical, they got a lot of it's a big house, and then they're on 16 acres with avocados. So they got pumps running water all over the land. And yeah, so, and then you can see there's 6 Franklin aPower 2 batteries, 15 kilowatt hours for each battery. So we have 90 kilowatt hours total. Now with the aGates with Franklin, the maximum you can back up is 64 amps continuous. So the 2 power walls, the system split in 50-50, literally 50-50. There's 2 Tesla Solar Inverters for each 50 panels, 25 and 25, and each one puts out 7.6 kilowatts, which gives us a total 15 kilowatts AC. Now originally I was going to go with the Fronius Primo inverter, but we ran into a snag as that inverter is not UL 1741SB certified. It is SA certified, and the engineers brought this up to me sadly at the end of the design, and they went, oh crap, it's Fronius Primo, not Gen 24. So that caused a little bit of a delay, but we quickly pivoted. We're just going to go with 4 Tesla Solar Inverters. These come with a 12.5-year warranty, so that's pretty good given the Primo only had a 10-year, I believe, and I'm not sure if it's one of the units that qualifies for that extended warranty of 12 years if you just register it online. Tesla, you get 12.5 years right out the gate. So it was a quick switch. Would I have liked to gone with a little bit of a higher AC rating? Sure, but microinverters, given the location of the equipment, it's 150 feet away from the batteries and the main electrical panel. I didn't really want to deal with that, and it's going to be a much higher wire size to get over there. And I think just speccing it out with the 430 watt modules, we weren't going to quite be able to back up the whole site. Just because of how those microinverters work. So we did oversize these modules at the end of the day to the inverters, but we ran the system analysis on it in open solar, and we're still going to generate 117% of their energy needs. So even with a little bit of clipping, it's still well within means. We're not even hitting the cap of the Tesla Solar Inverters, which is 170% or 1.7, or it would be 11.92 kilowatts. I think we're closer to 10 kilowatts, so it's not too bad. I'm not super bummed about it. They're missing out on a little bit of power, but honestly, they're not going to need to stress too much once the system's installed. So as you can see, you got your general notes, you got Anton's information over here, and this is the kind of plans you could expect from the engineers that I use if you were a contractor and needed guidance on this stuff. Not all engineers do solar plans, and you may not know what you're looking at or how to configure it. So as you can see, this is a pretty large lot right off the bat. And you can see, we have a lot of equipment over here. This is where the main electrical panel is. And there's also a generator, right? So there's a 30 kilowatt standby generator that we're integrating and splitting between the 2 Franklin sites. So really nice. And then the Tesla Solar Inverters are staying near the array. Now we're doing this so we don't have to install any rapid shutdown devices, because the NEC code basically says that as long as you can shut off the DC voltage within 3 feet of the array, then you're good. So by keeping the inverters at the array, we don't need to install Tesla MCIs. And so we're totally compliant in that configuration, which is really nice. So we have a lot going on here. As you can see, inverter, 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 and then there's a load combiner. So each Tesla Solar Inverter is going to be added into a sub panel at the end of the day. So big array, as you can see, just 100 panels across this. It's 4 and it's just going 4 up and down, and I think the rows is by 25. All right. So scrolling over here, this is a little bit of a closer one. And this is where that error was. It's 30 kilowatts, not 38 on the generator. It backfeeds 150 amps. So that's going to go into a generator sub panel, and then it gets split into 2 100 amp breakers, one for each aGate, using the generator auxiliary adapter. So both systems will be able to charge and power the home from the generator. It's sufficiently sized for it, and there shouldn't be any issues in that regards. Plus, we're including the load relay, the load management relay, which should ensure that we have black start capabilities in the event that the client completely drained the batteries to zero, the generator didn't kick on. The system will look to try and turn on the solar inverters to recharge them. So really nice. And then you can see we have the aPower units in groups of 2. And this is going to be really interesting when we look at the elevation page over here. So there's a lot of electrical equipment going on right here. We have 2 emergency shutdown switches. Basically, when first responders come out to site, if they turn those knobs, the whole system, batteries are shut down, the backup is disabled, it won't turn on the generator, the solar inverter shut down. It basically kills the site for emergency power. So all the solar equipment goes down, and then they can just shut off the electrical equipment like they normally would for any traditional site. And you can see this conduit run about 150 feet away for the solar inverters. So really nice. Now here's one of the elevation pages that we did. So this is a little bit more detailed oriented because there's a lot going on, and I really wanted it to be easily interpreted, not just by the jurisdiction but also by Anton, so his team has a clear guide on how to proceed with the installation. Now some of this is already in place, so this unistrut 2-inch posts, those are already technically there, but we're going to be reconfiguring it, removing some of the existing equipment that's on site and replacing it with this new equipment. We got a massive gutter box, which we're going to need, and then we have the 2 sub panels, and this is the 400 amp service that's existing. This thing's crazy. It literally is 400 amps for a main gear, and it splits off into a couple sub panels down below that go throughout the property and the home, but there's two main 200 amp breakers that go into a 400 amp automatic transfer switch, because that's what's currently there for the generator. So Generac has a 400 amp transfer switch. There isn't any 400 amp transfer switches in the battery space, sadly. I know some manufacturers has indicated that they're working towards having something like that. Generac doesn't even have a 400 amp transfer switch at this time for their own stuff, and they have their own battery system and solar equipment. So 400 amp is going to grow in popularity as sites grow in size, and we'll likely see it get make its round in development. I don't know who's going to do it first, but it'll be nice to see somebody develop that 400 amp automatic transfer switch, because it saves a lot of this, right? So you can see we have the Franklin aGate 1 and we have the Franklin aGate 2. So we have 2 Franklin aGates on site, and then they're going to receive that 200 amp power coming in to each unit, and then they're going to come out and power each sub panel, which then is feeding other sub panels throughout the property. They're basically 200 amp breakers in there, that's it. So it's pretty straightforward in that design. This is going to be the generator sub panel. So like I mentioned, the generator's breaker is going to come in, so that'll land here, and then it'll split into 2 100 amps and go to each Franklin aGate, so that way there's generator backup. And then those are the rapid shutdown devices, one for each system. So first responders just turn a little knob or push the button, and voila, the system's off. It's completely safe. The array has shut down, the batteries are shut down, there's no backup initiating, the generator won't come on, and then they can go to the main service and shut off loads as they want, or open up the sub panels and shut off loads as they want. I find these to be far more valuable than switchblade disconnects, as a first responder is just going to run around shutting off a bunch of switchblade disconnects and breakers, whereas this, they can turn a knob or push a button, lock it, and it's shut off, right? They do have, most of these have a protective cover, and or when you shut it off, you can tag it on the knob so it's locked into place and can't be reinitiated. Now, what we did with the batteries over here, we needed to consolidate space. So this is a utility pole coming in next to the service equipment. So power is overhead, but then it comes down the pole and then it goes into the 400 amp service. So what we've done here is we've rotated the power, the aPowers. So instead of them all just being stacked across each other and being really long, because this would be excessively long. It's already pretty long with the 3-foot gap that we need to put in front of each one. But we don't need to double up. Per the NEC, we can have equipment facing each other, and you can have 3 feet in 3 feet because you're only going to work on one unit at a time. So that's totally compliant for us to be able to do that. We don't need to have them 6 feet apart or have a special spacing. We can do 3 feet spacing between there, and we'll be able to service the equipment without any problems. It's important to note most of the Franklin servicing, like where you need to get in, is on the side of the unit anyways, which will have plenty of clearance on both sides of the unit as well. Now, another change that's occurring is we originally were going to have the sub panels to combine the aPower units. So we're combining 3 aPowers together and then going to each aGate. And now we need a sub panel to do that. So we put the sub panels right here, but we feel it'll be better to actually put them against parallel in the spacing. They're not going to block anything. They're just further back against the wall basically. And that's going to allow us to come out of the Franklins, go under, and come back up. These are going to be on 2-inch posts as well with unistrut going across, and there'll be 4, 5, 6 on this sub panel, 1, 2, 3 on this sub panel, and then they each go to their appropriate aGate. That's going to make it really easy for servicing it if you need to get in there and see if a breaker had tripped or anything, rather than trying to do this one, because getting these guys over there is a little bit harder. Obviously this one's really close, so it was just better to put the panels against the wall like that. At the ground mount, you can see the array configuration here that we have set up. So we have 4 Tesla Solar Inverters all ready to go, and then they're going to connect in parallel in the sub panel. So we'll have our DC inputs coming in, 25 panels on each inverter, right? And then say these 2 go to this sub panel, and then these 2 go to this sub panel, and then coming out of each sub panel, we're going to go to each aGate. And this will make more sense when we look at the single line diagram. So this is what's really unique about this site. So this site, there's a lot of panels, right? I mean, it's 100 panels. So you can see we have some discoloration going on over here versus right here. So this site already has an older solar system. It has older 250 watt modules in place using SolarEdge inverters. It's a pretty decent sized system. It's around like a 22 kilowatt. The problem is it's not enough power for them. They are still receiving a massive bill because it's just not generating enough energy. They also have a couple optimizers out that we can see in the monitoring portal, and instead of trying to just add on to the system, it was decided to consolidate space and let's just expand the array, and we can reuse the existing 2-inch posts that are more than sufficient. Yes, we need to upgrade the racking, but we can upgrade those 250 watt modules to 430 watts. So that made it a much larger system without adding much to the footprint, right? So we're adding a group of panels over here, and we're adding groups of panels over here. So basically on the left and the right, we're just adding a total of 10 posts to the array, which is rock solid for this type of expansion at the end of the day. We already got the concrete piers in place, and then we're going to add those in. We got ground lugs. We're using Iron Ridge XR1000, and we're specifically going to go with their extended rail. They have 2 lengths in the XR1000. They have a 17 plus foot one and a 16 foot one. By us going with the 17, I think it's 17 10 inches, those rails allow us to do 4 modules without having to do any bonding or splicing of rails. So it actually helps consolidate the cost and keep things down and keep it uniformal as well. So really nice that Iron Ridge has it available with the XR1000, which are strongly recommended for a ground mount system. But this is the value of working with a consultant like myself that has over a decade of experience in various types of projects. Now, we did model a couple different scenarios for this client. We looked at just adding batteries, we looked at just adding more solar to the existing array with batteries, and then we looked at replacing the entire system. The thing is, you know, with the entire, one of the big selling points to them was the ability for the entire system to be backed up when we replaced it all, because we could design it that way. With how the existing system was configured, the add-on wasn't going to be part of the backup, or the add-on would be backed up and only half of the existing system would. So it was like a give and take where we could, you know, reconfigure this whole system, make it all new, and make it all part of the backup. It does come back to some of the limitations on the backfeed capabilities for the solar to be AC coupled to the Franklin batteries, but we were able to make it work at the end of the day with the full replacement. So moving on to the single line diagram, and this is the ground mount array, so you can kind of see, like, this is a side profile. You know, so we're going to have 4 feet posts in the ground. The post itself, the 2-inch steel, is going to be about 3 feet in there, maybe a little deeper. That was a correction I sent back to the engineers to be like, hey, how deep are we going in here? I'm pretty sure it's going to be 3 feet, maybe 3 and like 30, a little longer, but maybe 42. But and then, yeah, you can see the iron-rich racking, fully extended. You got 4 modules on each rail, very clean, very simple, and we're just going to match it to the existing post. So the height and everything is going to be comparable to what's already on site, so we can just go boom and slap on the array accordingly. Now, getting to the single line diagram, this is where things get complicated because it's 2 systems on one site, right? So again, there's not a 400 amp automatic transfer switch. There's no 400 amp Franklin aGate. No Powerwall. Tesla doesn't make a Powerwall for that, or sorry, not a Powerwall, but their gateway. They don't make a 400 amp gateway. Enphase doesn't have a 400. Nobody has a 400 amp gateway. So when you're dealing with a 400 amp service, the only way you can address it and give that person full backup is to split it in 2. I've done it on multiple projects. It is a bit more complicated, but you are, and you know, it is a little more expensive because you got to buy twice as much of equipment, right? You have to buy 2 automatic transfer switches, 2 emergency loads panels. You have to split the array in half. Usually you're buying equal amounts of batteries for both configurations. There's just different avenues on different things. So you can see we're doing a group of 12 and a group of 13 for the inputs on the Tesla Solar Inverters, and then, like I said, that goes to a load center that's combining the 2 solar inverters. So here we go again, string of 12, a string of 13, very straightforward, nothing over the ordinary here. And then the batteries kind of repeat this pattern, except they're higher current. So we have 3 batteries to a 200 amp sub panel, and each one is 60 amps, and that is going to go to the backup extended lugs for this type of configuration. So Franklin has a breaker slot, but that's rated for only 2 Franklins. When you go above 2, you need to use their backup extended lug, which then goes where the backup loads feed, right? So very straightforward. Here is our external rapid shutdown device, as we're indicating on here. Here's that 2-pole 100 amp generator breaker. That's going to be in the aGate. That's what this is. This is the automatic transfer switch. And that's that sub panel from the generator, 30 kilowatts. It's 125 max current with a 150 amp overcurrent protection device. Now it's going into a 200 amp sub panel, and then it's splitting across these 2 units, each at 100 amps. So what's nice is that Franklin allows you to wire in both of them. So if one side of the site needs to turn on the generator, it can do that. And then through the relay, only that side of the site will receive backup power from the generator. If the other site needs it, then that one can enable it and also receive backup power from the generator. It's all stuff in the system configurations. And from my understanding, Franklin is looking at an ability for clients like this, as they've had a fair amount where they had to do split systems. And so in their monitoring portal, hopefully by the time the system's installed, who knows, but they're going to update it so that those types of clients can actually have the sites merged together. Rather than having to jump between 2 sites to see each one, you can just see it collectively in one portal and say, oh, there are my 2 aGates. This is how much power is flowing here. Here are my 6 batteries. I can see my solar energy flowing in there. That would be amazing to see them do that at the end of the day. But you can tell this is a pretty complicated site. So here's that 400 amps that's existing, and it is a true 400 amp main gear. So this isn't your normal residential 400 amp service. This is a freestanding 400 amp service that's truly 400 amps. A lot of the times when you see a 400 amp service on new construction homes, which I've done a video previously on, if you haven't seen it, I'm sure I'll do another one in the future. So be sure to like, subscribe, and share this video. But typically what happens is you have a 400 amp residential panel and it comes into the meter as 400 amps, but the second it goes past the meter, it's split into 200 amps. Similar to how this diagram is shown, but this panel actually has a 400 amp bus bar with 200 amp breakers on it. Totally different. These are bolt down breakers, which you don't typically see in residential. More often you see it in commercial and industrial applications where the circuit breaker doesn't snap into place. These actually bolt onto bus bars. So very different and really cool that this site is configured this way. But yeah, you rarely get actually a 400 amp bus bar on most 400 amp residential homes. Typically it's a 200 amp bus bar with a 200 amp breaker passing through to a sub panel downstream somewhere, and then there's a 200 amp feeding that bus bar right there. So that's sure a 400 amp panel, but it's really just 200 amp sub panels, more or less. This is actually a true 200 amp or 400 amp. And then you can see the system basically repeats itself on the second half. It's all symmetrical. It's completely even from the left to the right. So string of 12, string of 13, string of 12, string of 13, going into the Tesla Solar Inverters, bam, load center, combining those loads, and then that comes across and lands in the aGate. Very, very straightforward. And then we repeat ourselves because we're keeping some symmetry here and keeping the loads balanced. We got 6 aPower units for the other 200 amps that we're backing up, and those are being combined in a 200 amp sub panel. And then again, we're using the backup, the extended backup lugs kit. We're not using the Franklin aPower circuit breaker slot, and then we have the generator feeding into it as well, and we have that external rapid shutdown safety device. So this is a massive system. Really excited to be consulting on it and to be able to go out to the project and showcase it to you. There's not a lot of situations where I would come out to a job site unless it's maybe your first one and you want me to. With one of this scale, Anton and the client specifically requested for me to come out and oversee things and just, you know, give some familiarity to some of the project scope, so that way there was a good understanding of how things could progress. So as things move on this project, I'll be making some trips out there, recording some different points of it, and, you know, posting accordingly. So be sure to subscribe if you want to see this massive project progress and get installed. There are going to be under NEM3, and then we will be getting them the self-generation incentive rebate. I'll be handling that administrative work for them as well as the NEM paperwork. So that way this client can really benefit not just from the tax credit, but from the state rebates that are available for batteries. Now that is something I offer. As long as your installer is a developer, you as an electrician, if you're a solar installer or an electrician that wants to do batteries, you need to register with the Self-Generation Incentive Program Administration, so that way you can be a developer and then you would be able to offer rebates to your clients for installing batteries. I strongly believe that is going to be what, you know, allows organizations to move and progress forward after the tax credit's gone. And those that can process this paperwork are going to have a much better success, in my opinion, than those that can't. And it's not your cookie cutter paperwork. I mean, I see contractors struggle with NEM paperwork. I handled Anton's on one of his sites, and we literally got approval within a week, and it's just pending final inspection card. So I strongly encourage you to work with someone like myself that's familiar with the process and, you know, understands not just permitting and plans and sales and marketing, but also the interconnection agreements and any state rebates that might be available. I'm a very versatile person to help you with it because it can help you win these bigger projects. Here are some of the labels. If you were curious, this is the load studies and all that good stuff that needs to be included for engineering purposes, how it was calculated, what size wire we can use. There's a lot going on here. Most of it's number 10s for the array. The inverter gets bumped up for that because it's 40 amps. Number 8s. It doesn't look like we need to go to number 6s for the distance. Let me check. No, with the distance, we're still fine with number 8s. Franklin's, we're using number 6s. You got 3-aught. We kept a lot of the batteries near the equipment. The only thing that's a little far away are those Tesla Solar Inverters. And number 8 should be fine with little to no voltage drop. Here's some of the labels that are going to get installed on the site. Since there's a DC system, you're going to have the DC label. Of course, electrical shock hazard. Some of this is pretty straightforward. The system voltage of the batteries. This is very generic stuff. And then the most important one is going to be the placard right here. So this will be installed on the main electrical panel. So that way first responders are able to quickly see where all the equipment's at, which they're going to be standing in front of 90% of it, less of the inverters, 100, 150 feet away. So really cool. I'm really excited to be able to show this particular site off to you. And I just kind of wanted to give you an oversight of the plans. So if this is something that you're interested in and you need assistance and you're an electrician, you've got customers like, hey, I'd love to get a battery. And you're like, batteries aren't that bad. You're an electrician, you know electrical work. Batteries don't require you to get up on the roof most of the time, right? Maybe during a site visit, someone might need to get up there and get some details, but we can go into that. But at the end of the day, you really should be taking on these battery projects. There's going to be more service work coming up as solar contractors exit the space due to the tax credit and sales slowing, right? With that tax credit expiring, we're expecting 40 to 60% of solar contractors to exit the space. During the last study a couple years ago, there was only about 2,900 solar contractors, from my understanding, in the state of California. So if 40 or 60% of them, just close up shop, let's just call it 50, that's leaving about 1,400 still in the space. That's not a lot for a very large state. So they're definitely going to be fighting for business still in that regards. And with fewer jobs, that means prices are going to be higher, which means that gives electricians an opportunity to step in with higher skilled labor and just better customer service at the end of the day. I've worked with several different electricians. I just feel like you guys just care a little bit more than your run-of-the-mill solar contractor. And maybe it's because you got other work going on, or you've worked with this client several times. You weren't just turn and burn, like, okay, here's your solar, goodbye, never see you again. The solar industry has always relied on new business. And yeah, sure, they get referring business, but it's never return business unless it's warranty work. So with that said, warranty work or service work is going to be on the rise over the next couple of years as contractors go out of business and there's not going to be anybody to service that equipment. So I can assist you with that, get you onboarded with different manufacturers, like I said, get you introduced to these organizations, help you with your certifications, because a lot of them require you to be certified so you can commission the equipment. Tesla won't let you buy the equipment unless you've been certified. So that's important to note. And yeah, being part of Tesla's network is of great value because they are pretty strict about it. So, if you've been an electrician for a couple of years and maybe you've tried to get on with Tesla without any success, give me a call. I have some resources over there and I'm happy to help you get onboarded with them because they're looking for quality contractors, and they're looking for those that want to provide quality customer service and provide excellent installation support at the end of the day. So a lot of great opportunities. But yeah, that's kind of all I got. I hope you enjoyed this quick overview of this massive project, and I hope you subscribe to the channel to watch it get installed. I'm really anxious to get out there and show off Slazik Electric and Anton's work with his crews and their incredible electrical skills. So stay clean, stay green, and I'll see you in the next one.